Hi guys, let us look at question number 41 in Leetcode, first missing positive. It's tagged as a hard question. So let's read out the statement. You are given an unsorted integer array and you need to find the smallest missing positive integer. So I don't think this is a hard question. If you know the technique how to do these kind of questions, you will probably recognize them in a second and you can apply that technique and solve this kind of questions. So if you see a similar question, it is a 442 question, find all duplicates in an array. So you are given an array of numbers which are bounded from 1 to n and some numbers are duplicates. So here 2 are duplicates and 3s are duplicates and other numbers from 1 to n are missing. Here 5 and 6 are missing in the array. And for particular question in consideration, you need to find the first missing positive integer. So again, if you read out the examples, you can recognize that our answer would definitely lie between 1 and n plus 1, where n being the length of the array, right? So there would be a number missing from 1 to n plus 1 definitely in a given given array of length n, right? So our answer range is this, and find all duplicates in an array question. Here the numbers are bound between 1 to n and some numbers are duplicate. So whenever you have a integer array bounded from 1 to n, you can always think that I can somehow arrange or sort these numbers and basically put each number on its own position, on its own index. So I will rearrange this 3, 4, minus 1 and 1 array into something like 1, minus 1, 3 and 4. So our number 1 is on 0th index. Let's say our index is 1 base though. So it says 1th index, this is second index, this is third index, this is fourth index. So if I get into a habit of recognizing that whenever I have numbers from 1 to n, whenever I have unsorted integer array from 1 to n, I can arrange them and put all the numbers on their indexes, and the remaining numbers which do not match the potential indexes are the anomalies. So here, if you put the numbers on the index and you traverse from starting, you know, okay, 2 is the first missing positive integer in my given array. Now for the previous example, find all duplicates. If you arrange the numbers on their positions here, so you would arrange 1, 2, 3, 4, and then 2, 3, 7, 8. So you would definitely know that all these numbers are on their position, but 2 and 3 are the anomalies here. So 2 and 3 are the duplicates. Okay, let me take length of nums array into a variable. Now I iterate through a while loop because it is more convenient for manipulating the indexes. I take nums of I into a variable. Okay. Now if num is same as I plus 1, which means for 0th index, if my 1 is at position 0, and this is a check, okay, then do nothing. I will update my I. Okay. If my number is a positive number within the range, then I have to put it on the correct index. So if my number is within my range, then I need to put it on the correct index. So my j is actually num minus 1. So this is the index where I need to put this number on. So I'll swap my nums of I and nums of j. Right. And I don't know what new number has come to my position, so I won't update my I. Okay. Else, if there are negative integers or there are out of bound, this number is out of bound, is greater than n, then I don't need to do anything. This might be the first positive integer. I will keep it as b and just I increase my I. Okay. So now my array should look like, for the given example number 2, my array should look like this now. 1, minus 1, 3, and 4. Now I need to iterate through this array and find the number which is not on its position, which has a missing positive. So my answer is 1 right now, or actually I'll initialize my answer as n plus 1 because this might be the default answer if all the numbers are 1, 2, 3, 4. Then my answer becomes 4 plus 1, 5. So for I in range n, if nums of I is not equal to I plus 1, right, then return I plus 1. This is my missing integer. Then return answer. I don't need answer, I just can return n plus 1 here. I can delete this answer variable. Okay, let's try to run this code. Okay, let's try to submit it. I solved this question 4 years ago. Oh, it's time limit, that's it. Okay. Okay, so this particular case, when you have same number on j and I, so it will try to replace each other and get into a infinite loop. So we just need to check one more condition, if and num is not equal to nums of num minus 1. Let us try this on the test case 1, 1. Okay, let us submit this code. I think it should be accepted. Okay, great. So yeah, whenever you have this kind of questions where you have a foundation from 1 to n and you are given a unsorted array, try to think of a solution. What if you fit the integers onto their potential of on their respective indexes in a sorted manner? What will you get? What are the anomalies? Can the anomalies be your answer? Thanks for watching, guys. I hope you enjoyed the video. Please subscribe to my channel. It helps a lot motivate me to make further videos like this. Thank you so much. Bye.